I don't want to use them, so I'm going to give you one. How do you know you don't want to use spherical or cylindrical? I don't have any circles, and there's a much bigger reason. What dimensions are spherical and cylindrical in? 3. Am I integrating this 3 times? No. So what is the only transformation I actually know that I can use when I'm doing a double integral? Polar. And this is definitely not polar, right? Because there's nothing square, there's no circles or anything. So I know I don't want to use polar, I don't want to use spherical or cylindrical because those are 3-dimensional, which means I have to come up with a transformation of my own. So first thing I'm going to do is find the transformation. When we find our transformation, we go to define x and y, or u in terms of x and y, I should say. This is the first thing that I had said to do on the homework. So when we find the transformation, we look for what looks complicated. What's making this complicated? X plus y and x minus y, right? So the first thing I do is I say, well, let's make it look easier by assigning u to and v. There's no x. The first thing I do is I actually define it out. Now the problem with writing it like this is I know to translate the integral over, I'm going to have to find the Jacobian, and unfortunately I can't find the Jacobian like this, right? So the second thing I have to do is I have to solve or isolate x and y. That is, define a function of u and v that's equal to x. Define a function of u and v that's equal to y. Now to do this, I look back at what I have over here, and what can I do? Well, there's 2 methods for solving differential equations, right? Substitution and I can use elimination, right? Why can I use elimination on this? It's going to be rough, guys. Why can I use elimination? Going back to college algebra. What do you do when you do elimination? You add them or subtract them, right? So all I'm going to do with elimination is going to go ahead and add my equations. And when I do that, I'll get u plus v equals 2x. You can also use substitution if you prefer. That's what we did in class last time. Okay? So what I'm going to do now is I'm going to divide that 2 off, and we get 1/2 u plus v equals x, which is fantastic. So what I've defined here is a function of u and v. Okay, I'm going to do something similar in order to get y alone. I probably don't want to use elimination though. What will I use instead? Substitution, right? I'm going to come over here, and in order to get y alone, I'm going to go ahead and I'm going to solve for x and then plug it in, right? So coming up here, I'm going to go ahead and I'm going to say, well, I have x is equal to u minus y, right? This is substitution. Okay. All I did is move the y over, and now I'm going to plug it into the second equation. That is, I have v is equal to, and u minus y minus y. Okay, solving out here, v equals u minus y minus y. V equals u minus 2y. Anything that's good so far? Okay. V minus u equals negative 2y. Dividing by negative 2, I'll get 1/2 u minus v equals y. Everybody's okay with my divide by negative? I swapped the order. Okay. Hopefully this looks good, and what I have now are 2 equations. Right up here, x equals 1/2 u plus v, and y equals 1/2 u minus v. Now at this point, there's a couple different things I can do. First is I can look at translating over my bounds, or I can find my Jacobian right away. I can't remember, what order did I have you do it on the homework? Find the Jacobian first or translate over the bounds first? Bounds? Awesome. Let's do that next. we're going to do is we're going to look at the old bounds we had and we're going to try and translate them over. To do this, we're going to start by drawing the bounds we had for R. Then I'm going to take X and Y, right? And I'm just going to go ahead and I'm going to plug them in up there. So I've got some points. I've got the point 1, 0. I've got the point 2, 0. I've got the point 0, negative 2. And the point 0, negative 1. What we're going to do is I'm going to connect these before my region it on. Everyone's okay with that? It's so far? Okay. So what I'm going to do is I'm going to try and translate these over into some region S in the UV plane. Now to do this, I need to think about what the equations of these bounds are. I can't just use the individual points. I got to figure out what the actual equations are. So let's think about this here. Let's think about an easy one. Let's do this one. That little bound running down the side there, I'm turning green. What is the equation of that? I'm here at x equals 0. Do you agree? Now it doesn't run all of x equals 0 though, right? I've got some restrictions there. Y is restricted, right? And where is Y restricted between? Yep, exactly right. Freaking me out. Okay, let's talk about this one up here. I'll do the other easy one first. Okay, that one's going to be Y equals 0, right? And it's going to be restricted as well. When I restrict that one, what will be restricted, X or Y? X, and what will I run X in between? 1 and 2. Perfect. So we did the easy ones, which is always a good place to start. Now we've got to find our diagonals, right? These ones right here. Let's look at this bottom one. Now one thing I know is because this is a straight line going in between 2 points, I just need to find a linear equation, right? Now going back once again to our algebra here, to find the equation of this line, I need y equals mx plus b. I know it's a straight line because it's just in between 2 points. Okay? What am I going to find first to find the equation of that line? Slope, right? And so to find the slope, I need rise over run. So I really need the coordinates of these 2 points. Let me go ahead and write it out. That was 2, 0. And this was 0, negative 2, right? What's the slope of that line going to be? 1, right? I'll take rise over run. I'm going to get 1 out. That's good. Everyone's okay with how? Now, you can go ahead and you can write this as y equals 1x plus b, or y equals x plus b. You can plug in one of those 2 points to find b, but you actually don't need to. Why don't I need to plug in a point and solve out? What is b always? Y-intercept. Do I have my Y-intercept? What is it? Negative 2, right? So the equation of this line is y equals x minus 2. What's good? I want you guys to find the equation of this top one right here. Let me give you a second. Let's do the same process, trying to find the equation of that one. Okay, let's look at this one up here. What are we getting? We're getting y equals x times 1. Are we okay with y? That's true. Good? Okay, so now what I actually need to do is I need to translate my bounds over, right? In order to do that, I need to go ahead and look at my transformation. That is, I need to think about what I'm doing here. Let's look at x equals 0 first. If I take x equals 0 and I translate it over, what am I going to do? What am I going to do with that x? I gotta plug it in somewhere, right? Where am I going to plug it in? Well, what am I trying to defined here. I don't want an x and y, I want a u and a v, right? So if I'm going to plug x equals 0 in, where am I going to plug that in at? I'm staring at you guys, staring at the right place on the board. Someone just has to say it for me. You're all staring at the right place on the board. Half of you are staring at the right place on the board. You plug it in back here, right? We defined u and v in terms of x and y. So if we want those equations, all we have to do is come back over to the original definitions and plug x in. So if I have x equals 0, let's go ahead and plug that in. I'll have u equals, let's see here, positive y, right? From the first one. And v is equal to negative y. Does that look okay? Any questions on how I did that? Now, I don't want u and v defined in terms of y, right? That plane over there doesn't have a y in it. What am I going to do? I want to get u and v defined in terms of each other, not in terms of y. So what I really need to do here is get rid of this y. How can I get rid of the y? I can use substitution. What other method can I use? Elimination, right? Why is elimination perfect for this? So I cancel, right? I'm going to take that over here. We're going to erase this. Plenty of space for these problems. I feel like maybe I crushed your souls over the weekend, and that's why you're not talking to me. You were supposed to nod. Wasn't the response I was looking for? Okay, u equals y, v equals negative y. I'm going to go ahead and I'm going to add these using elimination. Which will give me u plus v equals 0, right? That's good. Am I going to try and get u or v alone here? Let me think about this. I'm going to try and get v. Why am I going to try and get v alone? Because v is my vertical one, right? This is my dependent. So v equals negative u. Now, I'm not just going to graph the line v equals negative u, right? Because I need to keep in mind that I had restrictions. What restriction did I have? I had y was between negative 2 and negative 1, right? Everyone's okay with that. That this restriction is coming from over there. Well, let's think about this here. If y is between negative 2 and negative 1, what is u going to be between? Well, I have u is equal to y, right? So I'd have u in between the same one. Okay? Any questions? No? So what you're telling me is I have this really nice line over here. I'm going to go ahead and take it and graph it. I know I have u's between negative 2 and negative 1. Well, negative 1, negative 2. And I have the line v equals negative u. How am I going to graph that? Line needs some points, right? To graph a line, normally I use points on it. So how am I going to get some points to graph this from? What values can I plug in? Negative 2 and negative 1, right? That's what u is restricted between, so let's do it. I'm going to plug in negative 2 for u, and when I plug in negative 2 for u, what is v? 2. Let's look here. 1 point right here. I now plug in negative 1, and when u is negative 1, what is v? 1. So I'm going to do that. I'm going to go ahead and graph that. Put it in green so it lines up. Right here. So u, right? V is equal to negative u. And that came directly from x equals 0. Question. That's good?